Well, good morning, everybody. As he introduced us from New Zealand, I am not a drilling engineer, as you can hear from that name, but I'm going to show you some things that we've learned in New Zealand as I expand on from what I was talking about yesterday morning. So hopefully we push the magic button. Okay, so we've got a lot to get through. There's the history. We talked about that yesterday. I'm just going to rattle through the first 10 slides quite quickly because the business end of it is at the back, okay? That's where the money comes in. Is everybody's interested in money? Yep. Okay, one person. Right, so we've got a bit of history. We've been around. We've done a few things. And we've advanced from that to this. Okay? So there's a DrillMax 350B. It's a big one for New Zealand. And but we've had a lot of experience. So as I said, we're just going to get through this. But some of the things we're on about, honesty. Up front regarding costs, right? So, quality assurance, we make sure that happens, right? Prioritizing quality. We don't want to do a bad job. We want to make a successful operation. But from our experience, we prevent pitfalls, making sure that we don't cut corners, trying to find a cheaper alternative. Safety is number one for us, though. Even the small things, everything is reported. It's not the blame game, it's to learn and make sure that everybody goes home safe. And that's our number one game. So our cultural change has been dramatic in the last 5 to 10 years in what we do and how we do it, working with our client. So our reputation for safety that is high on our priority list. But also that New Zealand Code of Practice of deep geothermal drilling, okay? That prevents a lot of mistakes in the whole operation. So you've got to think about that. And we've had some results. So this is in the Philippines many years ago, one of our older rigs. It's long gone, but we have some experience there. Now we have Rig 32, and that has been looking after us quite well. And through COVID, we got through that. We managed to keep a crew on station through the challenges that brought us. But remember, New Zealand is a long way from Italy, where the parts are made. So we have to order these things a year and ahead. So it takes us quite a bit of planning and logistics behind the scenes. And we run with a very small, lean team to do it all. But you notice in the picture, 3 mud pumps. There's some other things that we're going to talk about here. Anyway, this is some of the things we do under the drilling services. And we can help you in different ways. And train people, though. And we have been invited to help in commissioning projects and things like that. So, as I said, I'm racing through these quite quickly because I want to focus on the business end. And of course, we can carry on with these things as well. Avoiding advice on environmental constraints, management of drilling operations, regular reporting, and comprehensive well completion report. That's very essential. I can go back records to 1950 and find the original handwritten records of the first well drilled in geothermal New Zealand. Still relevant. That's the records that we want to look at. We're looking for 60 years, 70 years of records or more. And from that, if we want to get into that new geological area, what is the history? Who's drilled here before? And some of the paperwork I've seen from this part of the world is quite old as well, but it gives us some indication, but we've got to build on that. So each step is a learning curve. Advancements. So with the rig, we've advanced from the triple, that was rig 27, and we now take it only, that's the time frame, 1% non-productive time. Less than that, that's our object. So that's where we're trying to drive to. I know in the Philippines, they try to do that too, and they've learnt and gaining on us. So it's a challenge, eh? Anyway, we've moved from the traditional rig to the super single. And there's some things that we've observed from it. The air drilling decreases the lost circulation, noise reduction, very important when you're working around local people. We've had to overcome working nearby to towns, and we built up a wall, sound barrier around it to help reduce that noise. Safer operation, we don't have everybody up in the mast. Those sorts of things all make difference to us, and our team morale is improved. We've also made a big leaning on the health and safety side of it. There's some statistics from the previous years. Sorry I haven't updated this slide. But anyway, we've also got the upgraded skilling system. So our particular rig can actually move on to 4 wells, set it up on one site, and also we can make sure that the maintenance and certification and cycle of every 5 years you've got to go through and test and pressure test this and change that and keep all the certification up. All the drill strings checked every two wells, those sorts of things. Everything's numbered and corrected. Our asset management system is very, very impressive. We're always learning and improving on it. We always make mistakes, but you try to minimize them. So don't get hung up on that. Learn from them. Okay, so we have a bit of a few other things going on at MB Century. I said I'm just going to get through this quite quickly. And now we've also, we talked about moving from the one rig to the rig 32 and the 3 mud pumps, 1600 horsepower. Is this all good, guys? Am I too fast? Okay. Well costs. Now this is where the money starts. Obviously, this is you can see there's an industrial area in the background. Since this photograph was taken, there's now a 75 megawatt power station built on this location. This was taken about 15 years ago, this photograph, and but we paid it, and but the terrain, we had to change some things around that particular location. But these are the cost factors you have to consider when you're planning your wells or planning your sites. Think about the terrain. I've been to some remote places in Indonesia, Papua New Guinea, Philippines, for example, and it's all very well sitting in the head office back here in, say, Taipei, but when you get to location and the boss says, oh, we're going to put it here because that's the right spot, and you've got to shift half a mountain, or you've got a landslide potentially, or typhoon, wind issues, things like that, all have to be thought about, and they all cost. Obviously, a location of existing geothermal fields, but here in Taiwan, you're going to be drilling in brand new fields potentially, right? Obviously, the cost of the well design, diameter, the water supply. We've been asked to have a look, can we use seawater? No, we're not going to use seawater for cooling water. We need clean, clear water. We pump over 3,000 litres a minute down the well during drilling. We want water to flush those cuttings back to the surface and to make sure the well is safe. That is our barrier of control during drilling operations. When we switch to air drilling, there's another subject again. But we need good, reliable water sources. Obviously, the rock formation is a challenge. That's where you start selecting the right fits, but they cost money. And then you've got testing. Minute. 3,000 litres a minute is what we make sure, at least onto the rig site. We need that guarantee. So we lay in 6, 8-inch pipelines several miles from whatever river we can get. Put a little dam in there, we have backup pumps, and you have supplies, and you have backup systems. You do not want water to stop. Water to the rig site is essential. And then we talk about health and safety, environmental compliance. They all cost money. So these are some of the factors that need to be thought about. Here's our rig layout. So that's set up for 3 or 4 wells on one pad. It's 120 metres by 60 with plenty of room to move the machinery around. So when the trucks bring in the casing and take the drill pipe, etc., it's all the top right-hand corner is all the air conditioning and cementing systems. But we've got 4 generators on this site. This is a big rig in a sense, but it can draw 4 kilometres technically. But we allow plenty of room around so that we can actually walk. And we're fortunate in New Zealand that we do have that luxury. So from there, we make things happen. A big pond there to take all the cuttings as well. So that's a lot of rock is going to come out of the ground for 4 wells. But we've set up for that. All good? Okay. During construction, we're always monitoring optimization of drilling. Okay? The weight on the bit. The ability to drill with total losses. And that really scares the oil and gas guys. That is something they're not used to, right? Got a few nodding heads. Good. But also making sure that the open hole sections are deep enough to achieve the casing pressure. So don't get too cocky and drill ahead without making sure you've got the right casing set behind you. We learned in 1960 when we nearly lost a rig down a hole because we didn't set the casing right and we had didn't have a backup plan for the pump failure, and by the time we got there the steam was coming up the hole and we lost, and that hole lasted for over 12 years at least. It blew a crater 70 meters in diameter, 25 meters deep, and roared away as a natural geyser for over 12 years. And you could see the steam on the air from 120 kilometers away. We don't want that to happen in Taiwan. So think about it, guys. Start planning, backup plan, on backup plan. Okay? Water on water. Okay? Tools, equipment, pumps. You don't want a failure. And especially you're going to be in remote locations, so please plan accordingly. While I talk about that, you can go to website and find out blowout Wairaki 204 is the well number. There's a Google site you can go to and you can see the crater shaking. Anyway, we want to prevent stuck pipe. Why? Oh, no answers. Come on, I thought there was a drilling team in here. Yeah, drilling pipe stuck is not good. Okay, so that's caused by formation issues, etc. Bad well bore geometry, or good hydraulics to clean the well of cuttings using either air or water. That's essential, right? So you want to make sure. So there's times where we're drilling with total losses going down the well, and we keep pushing ahead. It's nerve-wracking for an oil and gas guy. Sorry? Yeah, exactly. So that's what you just got to keep going through it. Yeah. Thank you for answering. Appreciate it. Obviously, we're reviewing what takes the time. Average rate of penetration, flat spots, non-productive time, okay? From breakdown, our object is no code 8 is our plan, which is in our log system. That's when the client doesn't pay us. So we work on a day rate, okay? From that, there is a whole set of codes, and the client pays accordingly from those codes. Now, we have a breakdown for more than half an hour, I think it is. It's on us. The client, there's a bit of wiggle room in the middle there. So the contract negotiation needs to be worked through on what's the most efficiency for the client and ourselves. Obviously, we want to do the best job, we want to be efficient, and we want to get to the next well, but do it correctly and safely. So we need to look at what is the activity that's costing us big time. How can we improve that? So let's have a look at this one. This is how we've broken down some of our jobs. And tripping is the second biggest one. Well, yeah, it is. 15.8%. So. Aha, we're going to get to that. So in New Zealand, I'll answer the question. We changed from a tricone, went to PCD bits, and specially designed for the rock formations that we're encountering in New Zealand. So our client, who is supplying the bits, brought in somebody from the manufacturer, hired them to work in New Zealand and get those bits manufactured correctly for the rock formation. So we're pushing 300 meters on a bit, 500 meters on a bit, or more. So this particular record here is actually from an older job. But that's why we're getting 40 days and we finished a well 2,300 meters deep. I can show you on the phone. No, that's fine. I'm just saying that the last well we just completed was 2,031 meters, 37 days. And our rig shifts are approximately 12 days. Sorry? Yeah. I'll show you a picture in a second. So there's some opportunities, how we break it down and why, okay? This is how we're trying to get that efficiency. And like our friend here says, there's ways and means of doing it. Let's get efficiency, okay? This comes down to a bit of planning. Obviously, I've just looked at it a bit differently and where the bigger costs are of time. All good? Okay, so now, look at that. Tripping takes 7.1 days. Let's look at those figures again, right? Now, I've been talking to people up here using tricone bits, and they're spending all this time in and out of the hole to chase a bit. Oh, that's the cheapest bit. No, no, hang on, 7.1 days, look at that. That's quite a bit of your efficiency and your morale of your troops. In, out of the hole for a bit that hasn't done 50 metres, 100 metres, right? I don't know what your figures are, but I'm just being very broad-minded here that guys think about things. There's a bigger picture, and get your accountants and your financial people looking at this. Okay? They're the guys that pay for those bits and your time, but they're also paying for wages just to sit there and trip pipe. Okay, there's some of the differences. So the tricone, we only use a big diameter tricone for the first 150, 200 metres, if we're lucky, because they don't make that sort of bit on the other side. But we're putting in 10 3/4 liners, perforated liner. So the production casing is 13 3/8 and 10 3/4. So we're drilling a 12-inch hole. That's our predominant piece. So obviously that bit selection is quite important. Obviously looking at our RPM, weight on bit, hydraulics to find the best combination to be most effective in the job. And then checking our worn bit and stabilizers, making sure, and we're going to look at that in a second. During tripping, look at this, guys. Same task repeated multiple times. But with the, and people question why we went from a triple to the automated drill pipe rig. We actually did studies on it, and we ended up that we were actually slightly ahead using the computerized drill mech type automated rig to actually trip out, because the pipe is actually 14 metres long compared to the 10 metre or just shorter of the other one. You're pulling out a triple, you're pulling out 30 metres, but one 14 metre length. It all actually worked, but we had the safety factor. We didn't have anybody up in the mast, slipping and sliding during 2 o'clock in the morning in the rain, storms coming in. Those things have to be thought about. So this is why we went down this line, and our client helped us to drive this. Yeah, so that did make a big difference to us. Yeah, and using the right S-grade drill pipe as well. But 60 seconds is a loss of an hour and a half. Now, that's something to be thought about, because as we looked at it, 7.1 days is taken up just in tripping time in this particular example. How can we improve that? This is why I'm trying to challenge your thinking, to show you that there's ways and means of looking outside the box. And I want you to challenge yourselves and your management or wherever to make sure that you do better. But then we think about the equipment position ready to go. The next step, crew ready to go, all planning, okay? All equipment maintained. Breakdown during tripping, obviously we'll leave the open hole, right? We don't want that, so we make sure we look after everything correctly, maintain it. Scheduled oil services and maintenance on the plant is all done at the appropriate time to make efficiency, so that we don't waste time during drilling, because we don't want to leave an open hole situation. We don't want that, okay? But here, looking at this, obviously we are analysing the flat times, and that's when we do some of the other things that we need to do to plan the next steps of the well. And this is where I'm challenging your thinking. In this particular case, we ran a 9 5/8 liner. But then, how many bit changes? There's only a few on that list, but it may not actually reflect truly what happened. But it just gives you an indication of what you can do. Casing performance optimization. Yep, getting it all ready. I've seen some pictures up here of and it didn't have a catwalk on there, so we can't load all this pipe in front of you easily. To get things prepared, getting everything organised up in front of you. And then preparing the casing well run, because that takes time. And that's a dangerous operation. We've had accidents where things have slipped and not locked, or something's been put upside down, the pin wasn't put in. So everybody's got to watch each other's backs. It's not a blame game, it's making sure everybody goes home safe. BOPs, all set up. So there we are, we've got our 3 BOPs in this picture. And there's the annulus, the big 30-inch one there to start off with the conductor casing, and work our way down and slowly work our way through it. But this is planning and preparation in advance, because these things weigh 20 tonne. So they need to be lifted in at the right time and then move through. So we're nearly there. We've got mud pumps, we've got shakers, and we use 3 shakers. There's here 3 shakers, 3 mud pumps, there's 4 engines, 1 is just a backup. Staff and maintenance, we need to have the correct handovers right through there. Strict maintenance policy as well. That's very important on our equipment because we don't want a breakdown. And that's what we finish up with. So thank you one and all for your time. Thank you.